Hello, everybody. Hello, everyone.
Hello.
Hello.
Hey, Julie.
Oh,
Thank
hi.
you so much for joining me this morning. So we are going to do, oh, hello. Oh boy. So thanks so much for joining us. We are going to be doing an overview for the ArcGIS Maps SDK for JavaScript, our latest release, 4.26, that came out back in February. We think we saw many of you at our developer summit last month, and you got to see some of our latest and greatest technology. And today we're going to go through some of the highlights of our most recent release. So to start off, I'll introduce myself. I'm Julie Powell, and I'm Principal Product Manager for our Web Development Technologies. And I will also introduce Anne. You want to say hello?
Julie, you forgot to share a fun fact.
Oh, that's
the
right.
most important thing.
My fun fact is I love to make ice cream. I will take any request from my kids or my nieces and nephews, and no request is too hard. I will do it. All right, so that's my.
Do you take requests from us too? Is that allowed?
Yes, and come visit me in San Diego. I'll make you ice cream.
Sounds good. All right. Well, hi, everyone. My name is Anne Fitz. I'm a product engineer on the JavaScript Maps SDK. And my fun fact is that I recently became an aunt last week. So I'm super excited about that. All right. I'll pass it off to Androl.
Hi, my name is Androl Batsuk, and I'm a product engineer on the ArcGIS Maps SDK for JavaScript team. And my fun fact is I'm from Mongolia. And pass it off to Christian.
All right, cool. I'm Christian Ekenes, also a product engineer on the Maps SDK, working on data viz stuff. My fun fact is my first job out of college was working at a mining company, and I was the 5th generation of miners in my family. So grandpa, great-grandpa, and I think second great-grandpa worked at that mine. So that was fun. Not really, but kind of interesting. Anyway, David.
Hello, everybody. I'm David. I'm a software developer in the ArcGIS Maps SDK for JavaScript. And I work on visualization, graphics, analysis tools, mostly on the 3D part. Fun fact for me is that my name is in the last 2 Harry Potter movies. And this is because I worked in the visual effects industry before. And now
so
I bring
cool.
the magic of movies and games I bring now to the GIS world. So that's what I do here.
All right, thanks, everybody. So, okay, let's kick it off. And we're going to start with Anne. She's going to talk about highlight and some label updates.
Yeah. All right. Thanks, Julie. So first thing I want to talk to you about is a new feature where features in different layers can be highlighted with different symbols per layer. So this is done through a new property on the layer view called highlight options. And previously we only had the highlight options on the map view. So you could only set one highlight color and it would be used for all of the layers in your map. But now we can set different highlight options on each of the layer views. So you'll notice when I click in the map, we get this highlight, which is kind of a yellowish color. And then when we go to the next pop-up, the next feature, that's a different layer, we get a different colored highlight. And so this is done through the highlight options on the layer view. You can set the color and opacity for the halo, and then also a color and fill for the fill, the color and opacity for the fill. Yeah, in the future, we're also going to make it so that you can highlight different features within the same layer in different colors. So stay tuned for that. And also this feature is only in 2D right now, but we will be bringing it to 3D in an upcoming release. Now, the next thing I want to show is some updates to text symbols and labeling. So at this release, we added support for a background color and a border line. So right now you can see these are just our basic labels, but we can use these new properties the background color, the borderline color, and borderline size. And when I refresh, you'll see that we now get a background kind of call out symbol that adjusts to the length of your label. And you can play around with these properties, adjust the size, color of both the borderline and the background color to really enhance your labels and get the full control. So yeah, that was just a quick update from me. Next, I'm going to pass it to Androl to talk to us about different layers.
Thanks, Anne. So I'm here to talk about layer updates, and I'm going to start with the highlights of the stream layer updates. So we added 2 new methods to stream layer at this release, and they are send message to socket, which allows you to send messages to your server over the WebSocket, and send message to client method, which allows you to send client-only messages to your stream layer. So we added a sample. So users actually now can create client-side stream layers by taking advantage of the send message to client method. And we added the sample for this. So let's take a look at the sample. So as you can see here, there are 3 polygon features, and their symbols and labels are updating every second or so. That's because we are streaming new features to this client-side stream layer by streaming new features every second while updating the feature attributes. So let's take a look at the code. So to create and add a client-side stream layer to your map, you need to set the layer properties required by the stream layer schema. And those properties include object ID field, track ID field, geometry type, and also you need to set the spatial reference of the stream layer to match the spatial reference of the view. That's because we do not reproject features for the stream layers on the client side, as this can negatively impact the performance of your stream layers, especially if you're streaming large number of features with high frequency. But with that said, we will look into improving this behavior in a future release. So now we have the client-side stream layer. We need to start streaming new features to this client-side stream layer with a 1-second interval. To do that, we call the send message to client method with a message to stream features. So if you're using this method, we give you few predefined messages. You can send a message to stream features, a message to delete features based on their object ID fields or track ID fields. Also, you can simply clear out all the features that are available on the client side. So in this case, we are sending a message to stream features. So our message object has type property, and the value in this case is features. And then also it has features property, which contains array of Imagery JSON feature objects. So in our case, we are sending 3 Imagery JSON feature objects, and their geometries are polygons. And then if you see, we are updating the status, the value of the status field here randomly. And the status field is used by the layers renderer and label. That is why you see the symbols and labels updating on the map. Okay, so that is it for the stream layer updates.
Andrew, may I chime in real quick?
Okay.
I wanted to mention about stream layers. So this, I guess at a high level, wanted to say that now you can basically consume your real-time data via a stream service. So coming from Velocity or GeoVent, you can create your own custom WebSocket and consume your stream data. That was already available. And then 4.26, this new thing that Andrel's talking about means that now you can really not even worry about any of those other options, whether you're set where the stream's coming from, and basically hydrate your stream layer from any client-side data. So it enables that really fast update in the stream layer, and then you can really be handling it, managing it on your own. So it's just an additional option you have for where your data is coming in from. So just, yeah, that's all I wanted to say. So continue, Andrel.
Yeah, so just touch basing and what's new at 4.26. That's why I just kind of figured, yeah, people knew all the old options are available still. In addition to that, people can create client-side stream layers. Okay, so next, imagery layer. So we added 4 new methods on the imagery layer, which will allow you to carry out different mensuration operations. So using those 4 methods, you can measure area and perimeter, measure distance and angle, or you can measure heights of things on your images. And then also maybe you can just simply get the centroid of a given extent on your image. So check those new methods out. Next, I'm going to talk about our imagery tile layer. So we added the support for client-side raster functions for imagery tile layer at this release. And this feature was released in beta, as we will continue to add additional functions to the list. And then also we will work on improving the public API easier to use. We added a new sample. So raster functions are applied to the source data of your image that's visible within the map as you zoom and pan around the map. And then using raster functions, you can apply mathematical operations, self-statistical operations, data visualization, data management, analysis operations. So we added a new sample for this. So let's take a look at the sample. So on the map, you're looking at the imagery tile layer that references a tiled image service. And this tiled image service serves out the Landsat imagery of the Glacier National Park in one day of July of 2015. And this Landsat imagery has 8 bands, including red band and near infrared bands. And those 2 bands can be used to calculate normalized difference vegetation index, or NDVI, which tells you how green or half healthy vegetation is in a given area. So here we're looking at the result of the NDVI raster function applied to this imagery tile layer. So let's take a look at how this is done. So here we're creating a new instance of a raster function, and then we're passing an object. Our object has a function name, and function name in this case is NDVI. And then for the function arguments, we're passing in the red band index, near infrared band index, and then we're setting the scientific output to be false. That's because we want the resulting image of this raster function to have the pixel values between 0 to 255 instead of -1, 2, because we want to use the color map raster function to display the result of the NDVI raster function. And the color map raster function requires the input raster image to have a pixel values between 0 to 255. So next, we are creating another raster function. Function name in this case is color map. And then function arguments, for the function arguments, instead of having to set the color maps ourselves, we are passing in one of the predefined color maps from the raster function constants module. So in this case, we are a well-known NDVI3 color map as the function argument. And for the input raster, we are passing in the result of our NDVI raster function. So now we're creating a new imagery tile layer and then setting the raster function to the color map raster function. And this is the result we see. So now I can maybe just simply comment out the raster function. And then if we run the application again, we see the default renderer for this imagery tile layer, or for this image service. Okay, so before I move on, I just want to show you the SDK document for raster function. There are a couple of helpful links we put there, and then it may not be apparent why they're there, but I just wanted to show you. So we give you a link to the raster API raster function object, which takes you the REST API raster function object. So this document here basically explains all the raster functions that are available and tells you everything, gives you a good description of what each function does, and then what the function name is, and then also what the function arguments are. So if you're setting a raster function for the imagery tile layer, even though this is a REST API object, you can still use this as a guideline, what the raster function does and what the arguments are. And then also you will find another link to the list of client-side raster functions. And this will take you to this simple HTML page, which lists out all the raster functions supported by the imagery tile layer. Okay, so if you don't see the raster function on this list, means it's not supported on the imagery tile layer. So then you can click on one of the raster functions you see here. Then we give you a quick description of what the function does, and then we'll also give you a link to that REST document I just showed you. And then also we give you a simple code snippets that you can copy and paste into your raster function object. Okay, so next, media layer. So we added a web map authoring experience for media layer at this release, meaning that you will be able to add your media layer to map viewer and then be able to set its settings. And then also you can take advantage of the new source control points we also give you in map viewer, and then position your imagery exactly where you want it on the map, and then be able to save it with the web map and be able to reuse this map later with the settings you save. Okay, so last but not least, pop-up template support for tile layer. So if you have a tile layer that references a tiled map service, and then the map service was published with a query capability enabled, then now you can set a pop-up template for your tile layer. But if you're also, say, your tile layer doesn't have a query capability enabled, then you can still set up a pop-up template on your tile layer by setting the URL property on a sublayer to point to a feature layer. Okay, so let's take a look at this new sample we've added. Here we're creating a new tile layer pointing to a portal item that references a tiled map service. And then when this layer loads, we are getting all sublayers from this tile layer and then finding a sublayer based on its title. And then we are setting a pop-up template for this sublayer as you would for any other layer. So now if you click on your features, you will be able to get a pop-up template describing this sublayer. So this concludes my section for layer updates. Back to you, Anne or Julie.
All right. Well, now we're
Yeah,
gonna
thanks, Central.
go for it, Ann.
Sorry, I'm gonna steal the mic for a second, and I just wanted to say thank you to everyone so much for joining us. I see we have people joining from all over the world. I see Spain, Sweden, India, and then some people local to where we are too, in Tulsa and Orange County. So yeah, thank you for joining us. I know it's a different time zone where you all are, and so I appreciate you taking the time to be here with us. I also wanted to say, feel free to, if you have any questions while we're presenting this content, feel free to drop that question in the chat and we will get to it as soon as we can. So yeah, with that, I think it's Christian up next to talk about some feature aggregation updates.
Cool. Thanks, Anne. So for those of you who've been following what we've been doing with the JavaScript API for the last few years, you know that we're very concerned with improving performance and trying to leverage modern browser capabilities such as WebGL and attempting to allow you to bring more data in the browser than you could previously. So now you can render hundreds of thousands of features pretty seamlessly in the browser as long as you host them with hosted feature services. Well, with that comes the issue of being able to render or visualize that data effectively. And so we've added two very simple properties in the latest update of the SDK that allows you to, I guess, make your data, your dense data sets look a little nicer and behave better. So one of those is being able to set the sort order or the drawing order of features that you've rendered in your in a unique value render. So in this map, we're looking at over 100,000 car crashes in New York City. And basically they fall into one of three categories. It's whether that resulted in a fatality, an injury, or neither of the above. And the way that the data draws here is in the order that it's received from the service. But they all overlap and you can't really see you can't see patterns very easily. So new to unique value render. So if you look at my layer here, and then I've got my unique value renderer, there's this order by classes enabled property. If I enable this, it will then redraw the features in the order as you see them in the legend here. So This is great for things like being able to visualize priorities. So I would say that fatalities are probably a higher priority thing to visualize. So those are then drawn on top, and you can see all of the fatalities that occurred in the year 2020 throughout the city. And then below that, you can see all the crashes that resulted in injury, and then others that did not result in either. So again, very simple API or property that allows you to order based off of what you see in your renderer. And what's nice about that, you may look at this and say, well, haven't you already supported this? So if I look at the this example here, this is being able to configure feature sort order using an order by property on your layer. You can just set a numeric field and then order it based off an ascending or descending order. So if I just toggle this, you can see how the order changes. You can do that with string fields and an arcade expression, but what this example over here allows you to do is to save that to a web map as well. So the order that you establish in the renderer can then be saved in the web map, and then the client will know how to draw the feature order. So it actually makes it really nice to configure the order just all in your renderer. So that's that on feature sort order. I'm now going to show you this example of clustering. So we added a pretty minor, well, we added a single property to clustering, but it has a pretty major effect on your visualization, and that's this max scale. So we've had clustering for years now, but but clustering is very scale sensitive. It regenerates as you zoom in and out, which is nice. You can see how densities change at different scales, but there usually comes a point when the clustering no longer makes sense, and that's what this max scale does. Is you can choose this scale, view scale. So this is a scale of 1 to 50,000, and basically when the view zooms beyond that scale, clustering will turn off. So if I zoom in here to this city, you can see clusters are still enabled, but then as I zoom in further, all of a sudden they turn off because I, as the map author, have determined that clusters are no longer needed at these scales. So that was something that you'd have to set up a watch on your view to accomplish before. But now this is available in just a simple property. And again, this can also be saved to a web map. So if you save this to a web map and share it to your applications, they can take advantage of that behavior. Whereas if you set up a watch in your view, that's on an app by app basis. So pretty minor API update, but very significant implications there. So that's a wrap for what we've added in our data visualization capabilities.
Thanks, Christian. All right, we have a question in the chat from Cedric. This last pop-up template function is great. Any plans for vector tiles in the future? So he's wondering if we'll have pop-ups on vector tiles, and that is definitely something that we're planning. The way it's going to work is it'll have behind the scenes, it'll have a feature service that's running to power that pop-up experience on top of the vector tiles. We do hope to have that later this year. So thanks for the question. All right. And with that, let's go to David, and he's going to talk about 3D updates.
Yes. Hello, everybody again.
You're sharing the wrong.
Sorry. Yeah, sorry. So I want to talk about 3D updates for the 3D web part of the Maps SDK for JavaScript. And in particular, we have 3 features I want to talk about. The first one is the terrain shading. So we started improving the terrain shading a few versions ago, and this is now basically in a state where we improved the shading so that it's really much easier now to read the surface of the elevation geometry. So you see that the terrain here, it has all these like bumps, and we improved the shading so that you can basically much better read the surface. And for comparison, we started improving this in like 3 versions ago. So this is like in version 4.24. In the bottom here, you see that basically the shading was not existent. Basically, it's just like 2 colors, and you couldn't really read the geometry of the terrain surface. But now in our latest version, we have a really nice looking terrain, and you can really well read the surface. And this is part of our initiative to improve the realism of our API. So we always want to make the rendering in our API to improve and to be as good as possible. And this is a nice example where rendering is not just like a fancy thing, but it also really helps understanding data better. And therefore, this is why I like this example a lot. So terrain shading has been improved. And the next thing I want to talk about is this comes later, is actually 3D snapping. So we introduced 3D snapping also some releases ago, but this basically now, and we made snapping also to work with the analysis tools. So here is a data set we showed at the DevSummit plenary, and this is kind of a winter resort. And we basically are able now to use the analysis tools in the scene viewer to basically go in and snap the geometry. So when you do measurements, you get these guides. And if you click now, you can really be sure that your locations align with the geometry underneath. And this is working for feature layers and scene layers. And I'm showing this in the scene viewer, but this is, of course, part of the API. You can use the control key to disable snapping and enable it back again. So that's if you want to disable snapping while you're moving the analysis objects around, you can do this with the control key. So, and I can also show this for another measurement tool. So we have different measurement tools. Here's the area measurement tool. And here you see basically that it's now really easy to place the area measurement at, to place the area measurement at the exact locations of the rooftop here. And then I can close the area measurement. And so I have a good understanding of the geometry. And this is basically what we did with this snapping. So snapping is now also working with analysis tools. And the next thing I want to talk about is about the voxel layer. So here's an app which Raluca, one of our colleagues, made, which is showing the voxel layer capabilities. So this has been added. Voxel layer support has been added also to the API. And here we basically extended the rendering capabilities. And the app shows a volumetric dataset of the carbon monoxide distribution worldwide. So this is a really beautiful example of using scientific data visualization tools also in the API. So I talked about realistic rendering for the terrain shading, but we are also continuously improving on the data visualization end. And for data visualization, you have information visualization and scientific visualization, and the voxel layer, which is basically a volumetric dataset, which allows you to visualize volumetric data, is a really cool scientific visualization application, which you can now also use in the API. And we extended this in particular by supporting now slicing as well. So this is a voxel layer dataset where you have the different soil types for the Netherlands. And I can now use the slice tool to basically slice away the voxel layer and get basically a cross section of the layer distribution, of the data distribution. And further, this is subject of the same dataset. We have added pop-ups support for voxel layers. So if you now click, you basically can see pop-ups, and you can see the exact soil type and everything with a pop-up, for example, in this example here. And yeah, feel free to check out the documentation where we have added all the information about the capabilities for the voxel layer. And yeah, this kind of concludes the 3D part of the presentation.
Thanks, David. All right. So if you guys want to have a look at the release, you can, of course, go to the JavaScript website. We can go to my screen share. And we also wrote a blog that's summarizing all of the key highlights that you can have a look at. Raul, if you could share my screen, please. And something that's really exciting, my screen, please. Raul?
All right, while we're waiting for Julie's screen, just wanted to say if you guys have any questions at all, please pop them in the chat and we will get to them. And okay, go ahead, Julie.
Thanks, Anne. So yeah, you can get to the blog. I'll put the link in the chat if you want to have a look at that. But also, if you were unable to attend Developer Summit, or maybe you went and there's so many sessions even at the same time that you weren't able to see everything, you can actually view the recordings online. So here you can see all the plenary sessions, and then you have 130 different videos of the tech sessions. So these are really great resource for you to kind of dig into the different topics that you're interested in. To find it, you can even just search on Google for, let's see, Esri Kaltura. And the second link will take you to our media site. You can go to events and then conferences and Developer Summit. And you will find this year's Developer Summit down here. So check out those videos. It's a great resource for you. So if anybody has any questions, please feel free to put it in the chat. Let us know if you like this format of learning about our latest release. Share your ideas with us. We're always really interested in hearing from you. And please like the video, share it, subscribe to the channel so you can see future YouTube live sessions. So with that, does anyone else have anything they want to share? Any questions before we wrap up? All right, I think we're done. Thank you everyone for joining.
Thank you. Have a great rest of your day.
Bye.
Thank you. Bye, everybody.